Hello friends, welcome to this first lecture on the laboratory course that is devised for us to understand the practical aspects of process metallurgical techniques. I don't have to qualify it anymore, but we are in a rather uncomfortable and easy situation where we have to understand the practical aspects of certain techniques virtually. So ideally, you will be spending some time in lab doing something by yourself and learning out of it. But given the times we are in, we will be trying to learn the similar concepts but in a different manner. Now, I understood from your friend that in your previous semesters for courses such as these, online tools were used in order to get you involved and learn the practical aspects of the technique that you are studying. However, unfortunately, that mode or that approach will not be possible for us, particularly because we will be looking into the techniques that has largely to do with metallurgical or materials engineering. Now, supposing if you are considering a testing or an approach or a study that has to do with chemistry as a whole or physics as a whole, it is something that is common for all engineering streams, and given its wide range of audience, there might be tools that could be devised for this particular purpose. However, considering that the techniques that we are about to look into or the aspects that we are about to study are confined or restricted for a particular category of engineers, I don't think we have such tools available for us, and therefore alternatively what we need to do is, or what we will be doing is, we will be devising our own approach or our own technique in order to understand what otherwise you will be understanding from a laboratory setup. So this is what essentially we will be following for, depending on the techniques that we are studying or the topics that we are covering. We will be using our own approach, we will be devising our own approach in order to understand the practical aspects of the topic that we are looking into. And the other thing is, irrespective of the approach you are taking, be it in a lab or using an online tool, whatever might be your approach, in order to understand or in order to make sense of what you observe, you need to have some level of theoretical understanding. You need to have some level of knowledge about the theoretical concepts that are involved in order to decipher what is before you. So even if we do these studies in a lab setting, we need someone to guide us on what is happening in the behind the screens, or so to speak, or what is happening from a theoretical standpoint for us to make sense of what we observe physically. So irrespective of your approach in addressing or in looking into these laboratory techniques, we need certain degree of theoretical knowledge. And one of my motive in these lectures is that to provide you or help you with this theoretical aspect, so that whenever you are able to do this practical experiments, then these theoretical knowledge and these theoretical insights will come into play, and they will help you understand what you observe physically. So I hope it is sufficiently convincing for you to spend some time in looking into these lectures. So without further ado, let us get into the first topic on the process metallurgical technique. So in this lecture, what we will be learning about is a characteristic feature that is observed in a category of materials. So this characteristic feature is termed as, or it is referred to as, flash and fire point. So what essentially we will be doing is, we will try to understand what these features mean, and then we will see why it is relevant to us as a metallurgical and a materials engineer. So we have a feature that is associated with the category of materials and why it is relevant to us. And finally, we will look into the aspect of how one can measure these characteristic features. So this is what briefly we will be looking into in this lecture. Now, to put it in a down-to-earth terms, to put it in a more relevant terms, what essentially we will be learning in this course is that why one should not use mobile phone while in a petrol pump. So this is what we will be trying to address from a technical standpoint. So whenever you visit a petrol pump, you will find some warning notice stating that you should not use a mobile phone in a petrol pump. We will be trying to understand why is the case. Purely from a technical standpoint, we will try to understand why we should not use mobile phone in a petrol pump. Now, in order to do that, let us begin by considering the first feature, that is the flashpoint. So the flashpoint, like I've introduced earlier, the flashpoint is a feature, or both the flash and fire points are features that are associated with a specific category of materials or a specific category of substances. Now, when we say specific category, let us try to understand or unpack what the specific category of substance means. So these specific category of substances are flammable liquids. So these flash and power points are a characteristic feature, a characteristic properties of the flammable liquids. So flammable liquids, they have a property of features, they behave in a certain way. There is a characteristic property that is associated with them, and the way to measure this characteristic property, we need a way to express this, we need a way to quantify this characteristic property of flammable liquids. And this way to quantify the characteristic properties of the flammable liquid, one characteristic property of the flammable liquid is the flash and power, or rather flash and fire point. Now, as a metallurgical and materials engineer, how does the flammable liquid comes into our realm of our domain of study? So largely we are focusing on materials, and largely it's solid state materials, and we will consider only a liquids when we are talking about phase transformation. That is, when we are talking about solidification, is largely an area where we will be considering liquids. And as a metallurgical and materials engineer, let us understand where does this particular category of substance, this flammable liquid, comes into play. Now, if you consider our definition for minerals, we saw from an economic standpoint, from a resource standpoint, the definition of minerals include all the economically profitable substances that are present on the earth crust. So when we have such a definition for minerals, then this definition of minerals include both petroleum and coal. So as a metallurgical engineer and a materials engineer, it is also part of our domain to study mines and their products that we get out of mines. And in we are doing that, we are focusing on minerals, and from an economic standpoint, on an industrial level, when you are talking about exploiting resources, then we saw petroleum and coal form a large category of minerals. They are referred to as minerals, and they form a significant part of the minerals that we come across or that we need to understand as metallurgical and materials engineer. And since in order to exploit this resource, in order to exploit this mineral, petroleum and coal, we have to establish mines on an industrial level. And when we are establishing mines on the industrial level, this involves huge amount of human resource. This involves huge number of people working on it, and in addition to that, we will be investing a huge amount of monetary into it, or huge amount of monetary resources into it as well. It is vital for us to understand the safety aspects, the safety conditions that are associated with this mineral. And as a part of understanding the safety aspect and the safety measures of this particular mineral, that is coal and petroleum, we need to understand these features. So as a metallurgical and materials engineer, the reason for the flash and power point, or understanding or looking into this particular feature, that is flash and fire point rather, is because these features are an integral part of the minerals that are of a huge economical importance, and these minerals are mined out, and they are part of our technical domain, since they are also involved in the extraction of several other metals. So therefore, we are an integral part of both the mining aspect of these minerals and also the usage aspect of these minerals. And in both these areas, we have both a huge amount of human resource and also monetary resource that are involved. And it is our responsibility to take care of the safety aspect of both these industries, wherein the mining is done and other place wherein these minerals are being used. So we have a mine, we have an industry wherein the coal and petroleum are extracted, and we are a part of the industries wherein these coal and petroleum are deployed for the extraction of metals and materials. So in both these industries we are involved. So in both these industries, since they are large scale industries and they are involved huge monetary and human resources, it is important or vital for us to understand the safety aspects of both these industries, and that is the reason to why we are looking into these flash and fire points of these flammable fluids. Now it is rather comfortable for us to understand why or relate these flash and fire points or these features with petroleum, because by definition petroleum is a flammable fluid. How does coal come into play? Now again, the reason we are including coal in this definition is because by heating coal or by processing coal, it is possible for us to reach a setup wherein the coal is in the form of a liquid. The coal turns into a coal tar, and this coal tar also exhibits it does exhibit certain features that we are interested in, and that is the reason why in addition to petroleum we have coal included in it. So I hope now you are able to understand the relevance as a metallurgical and materials engineer to the flash and power point, again flash and fire point rather, and the reason essentially has to do with both mining of these minerals and also usage of these minerals. Mining and usage of these minerals particularly for extraction of the metals that we are interested in. Now, let us try to understand what a flashpoint is. Now, essentially, a flashpoint, we saw that it involves a flammable liquid. Now, when you have a flammable liquid and you begin to increase its temperature, and you have some sort of an ignition source at the top of it. So what you have is a flammable liquid here, and you have an ignition source at the top of it. This ignition source can be a small lit bud, or it could be a small source of fire, or a small source of fire, or not an actual fire but some sort of a small lit bud. So it is like a source wherein you have an increased temperature associated with it. So it is something you can imagine a matchstick that has just recently burned out. So you have it is often referred to as the lit bud. So you have an ignition source that is not explicitly a fire. Of course, it can also be a fire, but generally it is some sort of a source wherein it could ignite a fire. So we have that ignition source at one end, and you have a flammable liquid at the as the flammable liquid that you want to study in a setup. Now, what essentially a flashpoint means is that you raise the temperature of this flammable liquid, and at a certain temperature, what you observe is that this ignition source here, it activates a spark. It introduces a flash. So what essentially you are doing is you are having a flammable liquid and you are having a ignition source. So this ignition source, like I said, imagine a burnt out matchstick or some source which can ignite a fire in usual cases. Now, essentially you are increasing the temperature of the flammable liquid, and at some point what you observe is this ignition source it introduces a flash, it introduces a spark, and this is what we refer to as the flash point. So this is just a layman's understanding of what, or to help you understand the flash point can be described in this manner. However, since we are from a technical domain, a well-worded definition is expected of us. So the definition of flash point is something like this. Flash point is nothing but the lowest temperature at which a flammable liquid can form an ignitable mixture with air. So you can read it for yourself. So essentially what flash point is that it's a minimum temperature or the least temperature at which the flammable liquid can form an ignitable mixture with air. So that is what we refer to as the flash point. And the way we understand this ignitable mixture is formed is with the help of the source here. So this definition here is not much different from our understanding, but in our understanding we saw the involvement of the source and the involvement or the formation of a spark or a flash. Now the way this spark or the flash comes about is because we have a mixture of the ignitable mixture that is caused by the flammable liquid in the air. So that is what this definition expresses. So we saw from a physical standpoint that when you have a flammable liquid, when you increase its temperature, and along with it you have an ignition source, you will observe a spark at a definite temperature, and that is what we refer to as the flash point. From purely a technical, so that gives you a practical view. From purely a technical standpoint, the definition involves the formation of, so the definition, this particular definition of flash point involves the formation of an ignitable mixture at the lowest temperature. So it is the temperature at which the ignitable mixture is formed because of this flammable fluid. Now moving on to fire point. So fire point also is associated with the same setup. However, here the fire point is a temperature wherein instead of just a spark or a flash appearing, you would have a sustained fire. So the setup is the same. You would have a flammable liquid, you would have a source, and this source will introduce a flash above or at a definite temperature, and that we saw as flash point. Now when this source introduces a sustained fire, then we refer to that as fire point. So the distinction between flash and the fire point is that when you raise the temperature of a flammable fluid at a specific temperature, you would observe a flash or you would observe a spark because of this ignition source here, and that we refer to as the flash point. And now if you keep on increasing the temperature, you will arrive at a point wherein instead of just a flash appearing, instead of just a spark appearing, you have a sustained fire, and this is what we refer to as the fire point. Now these are the fundamental definition or the fundamental meaning of the flash and fire points. Now let us understand what is the theory behind it, the theoretical aspects behind the this particular phenomena or this particular feature that we observe in the flammable liquids. Now all liquids, irrespective of it as flammable or inflammable, the liquids on the surface of it, what you would observe is its components are present in the vapor form. So the liquid is made up of certain chemical composition, and these components that constitute the liquid in the form of the vapor, it's present on the surface of the liquid. This we refer to as the vapor, and the way we quantify this particular vapor is through its pressure, which we refer to as the vapor pressure. So let me repeat, any liquid, flammable or otherwise, the constituent of this liquid will appear in the form of gas or vapor on the surface of the liquid, and we measure, the way to measure this vapor is through its pressure, and we refer to it as the vapor pressure. The vapor pressure of a liquid, it increases with temperature, and since now we are dealing with flammable liquid, let's confine or restrict our discussion to this category of liquid, that is the flammable liquid. And the vapor pressure of this flammable liquid, it increases proportionately with the temperature. As you increase the temperature, the vapor pressure or the amount of vapor that is present on the surface of the liquid, it proportionately increases. Now this is what is being expressed in this relation, wherein Vp, we refer to Vp here as the vapor pressure, which increases with the temperature. Now when this vapor pressure becomes equal to that of atmospheric pressure, again these concepts you would have learned in your school days, it's just a way to refresh it. So what essentially happens is, when this vapor pressure becomes equivalent to that of the atmospheric pressure, then the material, the liquid begins to boil. So the liquid no longer wants to be in the liquid state, it begins to boil, it transforms into the vapor form, and this is what we refer to as the boiling temperature. So the temperature at which the vapor pressure becomes equivalent to that of the atmospheric pressure, that is what we refer to as the boiling temperature. but this definition comes directly, or it stems from the description of the vapor and its pressure. So now what we have seen is that the vapor pressure increases with temperature, and as if you keep on increasing, the vapor pressure keeps on increasing, and at one point the vapor pressure becomes equal to that of the atmospheric pressure, and then the liquid starts to boil. So before attaining such a state wherein the liquid starts to boil, before the vapor pressure becomes equal to that of the atmospheric pressure, in the flammable liquid, there is a critical vapor pressure that introduces or that turns the air into an ignitable mixture. So let me repeat, before the vapor pressure becomes equal to that of the atmospheric pressure, before the flammable liquid begins to boil, there exists a critical value, there exists a critical vapor pressure wherein the vapor turns the air into an ignitable mixture. So there is a critical temperature, or there is a critical vapor pressure, because of which air is now ignitable. Now that critical vapor pressure that turns the air into an ignitable mixture is what leads to the flash point. So we saw that flash point is the minimal temperature wherein you would observe a flash or a spark with the help of an ignition source. The reason that we observe this is because as you keep on increasing the temperature, the vapor pressure keeps on increasing, and at certain point, because of this increased vapor pressure, this increased vapors, it mixes with the air and it forms an ignitable mixture. And this ignitable mixture is what leads to the formation of a spark or a flash because of this ignition source. And this is what we refer to as the flashpoint behavior. So this is observed in flammable liquids because the vapors of these flammable liquids only form the ignitable mixture with air. So the flash point and also the fire point, they are both related or intricately linked with the vapor pressure of the flammable liquid. So there is a critical vapor pressure at which the air which mixes with this vapor becomes ignitable, and this vapor pressure is ultimately what leads to the formation of the spark or the flash, which we term it as flash point. So it is like the vapor pressure, it essentially governs the ignitable mixture that ultimately leads to the formation of flash, which we call as the flash point. And in the same way, when we keep on increasing the temperature, the vapor pressure becomes sufficiently high in order to sustain this fire, and that we refer to as the fire point. So ultimately, even though physically we increase the temperature and physically we see the flash, physically we see the fire being sustained, it is ultimately governed by vapor pressure and ultimately governed by critical vapor pressure. So when we talk about critical vapor pressure, it is the pressure that turns the air into an ignitable mixture, and once you have an ignitable mixture, you have the flash point. And when you keep on increasing the vapor pressure of the flammable liquid, this flash point then becomes a fire point wherein you can sustain the fire. Now the way to measure this flash point and fire point, because these are specific temperature and it should be possible for us to measure them. So these are measured in a laboratory setting by using this apparatus, Penske and Martin's apparatus. Now this apparatus is so rather, the application of this apparatus is so wide. It's not only used, at least from the perspective of a metallurgical and materials engineer, it is used in largely used in a mineral setting or in a setting wherein coal and petroleum is involved. This is also used in other settings, wherein even in pharmaceutical settings, in other settings wherein the flammable liquids are being used. So given this application or this wide range of application in which this particular flash and fire flash and fire point come into play, this particular apparatus is being produced in quite a large quantity, and even in Amazon this particular apparatus is available for close to 8,500 rupees. And this image, of course, I took this image from Amazon just to show you how relevant is this particular apparatus is to the industries. And the reason, again, we confined ourselves to petroleum and coal industries because we are not interested in all the industrial applications, but the industrial applications that are relevant to us. However, it does not mean that the flash and fire points, again, fire points are not exclusively associated with the mineral industries alone. So they are used or involved in a wide range of industries where the inflammable liquids are being employed. So instead of getting into the technical aspects of this particular apparatus, of course, how this apparatus works, there is a separate video for it that is being offered by I don't know, one of the manufacturers. The link to it, I will maybe post it in the description. Maybe if you have time, you can look into it. So instead of getting into the individual components that are involved in this apparatus, I will just give you a brief overview of how this apparatus works. So what essentially this apparatus comprises of is that it has an heat source and it also has an ignition source. So essentially you will be introducing the liquid that you want to study into this apparatus, and then you will start heating that liquid, and you will also simultaneously introduce the ignition source, and you will identify the response of the vapor that comes from the flammable liquid to the ignition source that you have introduced. So you have a heat source that will heat up your flammable liquid, that essentially increases the temperature of the flammable liquid, and this increase in temperature increases the vapor pressure, and you introduce this ignition source into this vapor in order to study its response, and you will also measure the temperature in which you observe this flash or a sustained fire. So using this setup, so this is what the representation of what essentially happens in this apparatus. So like I said, to get into the nuts and bolts of what is happening or what are the different components involved in this apparatus, I will share a link. If you are interested in it, you can have a look at it. It's not a very long video, it's about 10 or 12 minutes, I believe, not more than that. So you can look into it, you can look into what are the different components and how it's being used. So it's a very interesting video, I encourage you to look into it. But the fundamental principle behind it is it's what's being shown here. You have a heat source, and using that heat source, you try to increase the temperature of the flammable liquid, and then using the ignition source, you try to understand how the vapor responds to this ignition source, and you will keep on. So of course there will be a thermometer involved in order to measure the temperature of the flammable liquid, and at a specific temperature you will observe a flash that is being formed, and you will then refer to that as flashpoint. And at a certain temperature you will observe that you have a sustained fire. Again, sustained fire doesn't mean that you let the fire continue for quite a long time. It means that you allow the fire to be sustained for close to 5 seconds, and that temperature would be your fire point. So this is how in a laboratory setting you will try to ascertain the flash and fire point of the flammable liquid. Ultimately, so this is what we mean, or this is ultimately what we refer to as the flash and fire point, or rather flash and fire point. So essentially they have to deal largely with the ignition of the vapor that are associated with the flammable liquids. Now, having understood what a flash point is and what a fire point is, now it is your work to relate these features of the flammable liquids to what you observe in a petrol pump. Now, this would be, so generally in a practical class, what you will essentially be doing is you will be doing the most of the work. That is how a practical course works. You will be doing most of the work and you will be learning out of it. And let us try to replicate the same sort of a pattern, even though we are doing this in a virtual mode. So what I essentially want you to do is, as a part of, say, the first assignment of this particular course, is that using this understanding of what a flash and fire point is, try to make sense why we should not use cell phones in a petrol pump. So let me repeat, as the first part, or as the first assignment for this course, again, since it's a group activity, you can discuss amongst your group, or within your group rather, and then try to make sense why, based on this understanding of flash and fire point, try to make a technical argument why one should not use mobile phones in a petrol pump, particularly while pumping petrol or while filling in the petrol, why one should not use his or her mobile phone. So this, please try to, you can write a report, a single page report on why, based on your understanding of flash and fire point, why one should not use mobile phone, why the petrol is being filled in. So this you have to help me understand, or the report should be on and answering this particular condition, why one should not use this phone, using from based on your understanding of flash and fire point. Supposing you think that flash and fire point it has nothing to do with this particular condition, it is a different phenomena, it's a totally different feature, it has nothing to do with using mobile phones in a petrol pump, even that you can write it in your report. So what I essentially need is, what can you relate flash and fire point to this particular condition of not using mobile phones in a petrol pump? That will be your first assignment, and like I said, all I need is a one-page report relating or even arguing that these flash and fire points, they don't have anything to do with this cell phone and petrol pumps, or it has something to do with this, and this is the relation. So this would be your first task, or this would be your first assignment for this course. So let me wind up with this. So I hope you are able to understand the theoretical concepts that are behind the flash and fire points that we observe in flammable fluids. So we will see ourselves in the next course. Goodbye.